Welcome to Lucid Mind Chemistry channel. In this video, I have put together some questions related to the topic Allotropes of Carbon. For links to other topics and question timestamps, please visit video description. Question 33. Carbon exists in several different forms. Two of these forms are Buckminster fullerene and graphene. Buckminster fullerene is a fullerene allotrope of carbon. Which statements about Buckminster fullerene and graphene are correct? Number 1. Both have delocalized electrons. Now in Buckminster fullerene and graphene, carbon makes 3 bonds. And the 4th bond is a pi bond. And because of the presence of that pi bond, the electrons are actually delocalized. Second part says Buckminster fullerene has a giant molecular structure. No, this is not correct because Buckminster fullerene is made up of 60 atoms only. So it is not a giant molecular structure, it is a simple molecular structure. Third one says the carbon atoms in graphene forms a tetrahedral lattice. As we know that the carbon is making just 3 sigma bonds, so it is not tetrahedral, so this is also wrong. So the only option that is correct is 1. So the answer is D. Question. Let's start. Question 1. In which carbon allotrope are all electrons localized? Now localized means that the electrons are fixed. We can see there are 2 types of covalent bond. One is sigma covalent bond and another is pi covalent bond. In sigma covalent bond, electrons are always localized because they are fixed between the 2 atoms. They cannot move freely, while pi electrons can move freely. So there are 4 options: Buckminster fullerene, diamond, graphite and graphene. Let's find out the number of sigma bonds in each of these. So in Buckminster fullerene, carbon makes 3 sigma bonds. In diamond, carbon makes 4 sigma bonds. In graphite, again we have 3 sigma bonds. In graphene, we have 3 sigma bonds. Now the 4th electron in Buckminster fullerene, graphite and graphene is not localized. It is delocalized. So the only option in which all electrons are localized is B, diamond. Question 32. Buckminster fullerene is a fullerene allotrope of carbon. Which statement about Buckminster fullerene are correct? 1. Buckminster fullerene is a giant covalent molecule. As we know that there are only 60 carbon atoms present in one molecule of Buckminster fullerene, so therefore it is not giant, it is simple molecular. 2. Buckminster fullerene has delocalized electrons. As we know that in Buckminster fullerene, carbon makes 3 sigma bonds and one of the electron is involved in the pi bonding, so therefore due to the pi electrons there is delocalized system, so therefore 2 is correct. 3 says Buckminster fullerene has strong intramolecular bonds. Intramolecular means inside the molecule. Now we know that in the Buckminster fullerene molecule there are 60 carbon atoms and all of them are covalently bonded with each other, so therefore the bonds are strong. So this is also correct. So the option is C. Question 30. Question 33. Carbon can exist as allotropes which include graphite, diamond and a fullerene. Which statements are correct? Option 1. All 3 allotropes contain covalent bonds. We can see that in graphite, carbon makes 3 covalent bonds with 3 other carbon atoms. In diamond, what happens that carbon makes 4 single covalent bonds with the other carbon atoms. In fullerene, the bonds are similar to graphite and carbon makes 3 covalent bonds with other carbon atoms. As carbon is a nonmetal and nonmetal makes covalent bonds, therefore option 1 is correct. Option 2, all 3 allotropes are giant molecular. We can see that graphite is giant molecular, Diamond is also giant molecular, but fullerene is a small molecule made up of almost 60 carbon atoms. So therefore option 2 is incorrect. Option 3, all three allotropes have delocalized electrons. We can see in the structure of graphite, carbon makes 3 covalent bonds, and also in fullerene, carbon makes 3 covalent bonds, and the fourth electron of carbon is free to move, so therefore in graphite and fullerene we have delocalized electrons. But in diamond, what happens that all 4 electrons of carbon are involved in covalent bonding, so therefore no free electron is present. So diamond does not have any delocalized electrons. So option 3 is also incorrect. So only one option is correct, so therefore answer is D. Thanks for watching. If this was useful, please do like, subscribe and share.